Watch a lightning strike. You see a brilliant flash, a jagged bolt connecting cloud to ground. It looks like it's coming down, from sky to earth, lightning striking down. That's what everyone sees. That's what everyone sees. Lightning strikes down, except it doesn't. The bright flash you see, the main discharge, the bolt that lights up the sky, that's going up, from ground to cloud. You've been watching it backwards your entire life. This should completely change how you see storms. Here's what you think happens. Clouds build up electrical charge. Too much charge. It needs to discharge. A bolt of lightning shoots down from the cloud to the ground, strikes a tree, a building, the ground. You see the flash. You hear the thunder. Lightning struck down. Simple, obvious, wrong. What actually happens is far stranger. The visible lightning bolt, the bright flash everyone sees, travels upward, from the ground to the cloud. Not downward, upward. The entire brilliant discharge you call a lightning strike is climbing, rising, going up. And you can prove this. Slow motion cameras capture it, frame by frame. The bright flash moves upward, unmistakably, definitively, up. But wait, if lightning goes up, why does it look like it's coming down? Because something does come down, just not the part you see. There are two processes, one invisible, one visible. The invisible part comes down, the visible part goes up. And your brain only registers the bright flash, so you see it going down when it's actually going up. Let me explain how this works. Start with a thunderstorm. Massive, towering, cumulonimbus clouds reaching 10 kilometers high. Inside, violent updrafts and downdrafts. Air moving at hundreds of kilometers per hour. Ice particles colliding. Water droplets freezing. All this motion creates charge separation. The mechanism is complex. Ice crystals and grapple, soft hail pellets, collide in the turbulent air. Electrons transfer. Smaller ice crystals become positively charged. They're light. Updrafts carry them to the top of the cloud. Heavier grapple becomes negatively charged, falls toward the bottom. The result is a giant battery in the sky. Positive charge at the top, negative charge at the bottom. Sometimes 100 million volts of potential difference. Those electrons want to get to the ground. The ground is neutral, or slightly positive. Opposite charge attracts. But air is an insulator. It doesn't conduct electricity easily. Electrons can't just flow through air like they flow through a wire. Air resists, so the charge builds up more and more. The electric field between cloud and ground grows stronger. Millions of volts per meter. Eventually it reaches a critical threshold. The air breaks down, ionizes, becomes conductive. But this doesn't happen all at once. It happens in steps. The breakdown starts at the cloud. A channel of ionized air begins to form, moving downward toward the ground. This is called a stepped leader. It's faint, almost invisible. It moves in discrete steps, about 50 meters at a time. Pause, step, zigzagging downward, following the path of least resistance through the air. The stepped leader carries negative charge down from the cloud. But it's not bright. The current is relatively small, maybe 100 amperes. Sounds like a lot, but for lightning, it's weak. The leader is dim. You can barely see it. Most people never notice it at all. High-speed cameras can capture it. Sensitive instruments can detect it. But to the naked eye, in real time, it's essentially invisible. The stepped leader doesn't move continuously. It jerks downward in discrete steps. Each step is about 50 meters. The leader pauses, ionizes the next segment of air, steps forward, pauses again. The whole process takes about 20 milliseconds to cover 2 kilometers from cloud to ground. That sounds fast, but it's actually quite slow for an electrical phenomenon. The return stroke will be 100 times faster. Why does it step? Because ionizing air requires enormous energy. The leader can't maintain a continuous discharge. It breaks down the air in segments. Each step creates a weakly ionized channel. The charge accumulates. Then the next step begins. The path is jagged because the leader follows the easiest route. Air is not uniform. Some regions have more moisture, more dust, more ions. The leader seeks these regions, takes the path of least resistance. That's why lightning bolts zigzag. The stepped leader descends, getting closer to the ground. As it approaches, something important happens. The electric field at the ground intensifies enormously. The approaching negative charge from the leader induces positive charge in the ground, especially at tall objects. Trees, buildings, antennas, anything that sticks up. The positive charge concentrates at the tips. The field grows stronger. At some point, usually when the leader is about 100 meters above the ground, the field becomes strong enough to ionize the air upward from the ground. A streamer launches, a channel of ionized air rising from the ground, sometimes from a tree, sometimes from a building, sometimes from a person standing in an open field. The streamer climbs, reaching upward, trying to connect with the descending leader. When the upward streamer meets the descending leader, connection is made. A conductive channel now links the cloud to the ground. Electrons in the cloud can flow. And they do, massively. Suddenly, billions of electrons rush down through the channel. But here's the key. The visible lightning bolt you see is not those electrons flowing down. It's the return stroke traveling up. The return stroke, that's the bright flash. When the connection is made, the lower end of the channel near the ground becomes highly conductive. Electrons flow in. The channel near the ground lights up intensely, extremely bright, and that brightness propagates upward, like a wave traveling up the channel, from ground to cloud, at about 1/3 the speed of light, 100,000 kilometers per second. Incredibly fast, but measurable, and definitively upward. Think of it like this. Imagine a long tube filled with gas. The bottom of the tube connects to a high-pressure tank. The top is open. You open the valve. Gas rushes in from the bottom. But the pressure wave travels up the tube, from bottom to top. The gas is flowing in one direction. The wave propagates in the opposite direction. Lightning is similar. Electrons flow down through the channel. The bright return stroke propagates up. The return stroke is what you see. It's incredibly bright. Peak currents of 30,000 amperes, sometimes more. Temperatures of 30,000 Kelvin. Hotter than the surface of the sun. The air around the channel is heated explosively, expands violently, creates a shock wave. That's thunder. The sound of superheated air exploding outward from the lightning channel. But the flash you see is traveling upward, from the point of contact on the ground up to the cloud. High-speed cameras prove this. Frame by frame, you can watch the bright flash climb the channel, starting at the ground, moving upward, reaching the cloud in about a millisecond, 1,000th of a second, too fast for your eye to track. You see the whole channel light up at once, but it doesn't. It lights up sequentially, from bottom to top, ground to cloud, up. Now here's where it gets more complex. The first return stroke is not the only one. Often after the first stroke, a new leader comes down. This one is called a dart leader. It follows the same channel as the first stroke, moves faster, doesn't step, just glides down. When it reaches the ground, another return stroke fires upward, then maybe another dart leader, another return stroke. This can repeat several times, rapidly, all within a fraction of a second. Each return stroke travels upward. What you perceive as a single lightning flash is often multiple strokes, each one traveling up, happening so quickly that your brain merges them into one event. But slow motion video reveals the individual strokes, each one climbing from ground to cloud, each one starting at the bottom and propagating upward. This is not theoretical, this is observed, measured, photographed. You can watch slow motion lightning videos online. You'll see it clearly. The bright channel appears at the ground first, then extends upward, climbs to the cloud. Every time, the visible lightning bolt goes up. And this matters for safety. You're told to avoid tall objects during storms. Trees, poles. Why? Because they launch streamers. When the step leader approaches, tall objects send streamers upward first. The connection happens there, the return stroke fires from there. Massive current flows through, trees explode. Water inside turns to steam instantly. The trunk splits apart. Open fields are dangerous too. If you're the tallest object, you become the launch point. Your head sends a streamer upward. If it connects, you become the lightning rod. The return stroke fires from you. 30,000 amperes through your body. Fatal. This kills people every year. Golfers, hikers, people in open spaces thinking they're safe because there are no tall objects. They are the tall object. So why does everyone think lightning strikes down? Because the invisible part comes down. The step leader descends. It initiates the process. It creates the channel. But you don't see it. What you see is the bright return stroke, and your brain assumes the bright thing is the thing that moved. The bright flash appeared. It must have come from the cloud. It must have struck down. But that's wrong. The bright flash is the return stroke, and it travels up. Here's another thing most people don't know. Lightning can initiate upward from the ground without a descending leader. This happens at very tall structures, skyscrapers, radio towers, mountain tops. If the structure is tall enough and the electric field is strong enough, an upward leader can launch from the top. No stepped leader needed. The upward leader climbs toward the cloud. When it connects, a downward return stroke can occur. But even in this case, the initial bright flash is often upward, starting from the structure and propagating toward the cloud. This upward initiated lightning is less common than cloud-to-ground lightning. But it happens, especially at very tall structures like the Empire State Building or the CN Tower. These buildings are struck by lightning dozens of times per year, and many of those strikes initiate upward. The building sends a leader up. The cloud responds. A return stroke may come down, but the initiation is upward. Think about what this means. The thing you call a lightning strike, the bright flash, the bolt everyone sees, is not the cloud attacking the ground. It's the ground and cloud connecting. The stepped leader comes down, invisible. The streamer goes up, invisible. They meet. They connect. The return stroke fires up, bright, visible. That's the lightning bolt, and it goes up. Now let's talk about what happens to the energy. The return stroke carries massive current, 30,000 amperes, at very high voltage, millions of volts. That's enormous power. Where does it go? Into heating the air. The channel temperature reaches 30,000 Kelvin. The air ionizes completely, becomes plasma, glowing plasma, radiating light, ultraviolet, visible, infrared, all wavelengths. That's the flash you see. The heat also causes rapid expansion. The air in the channel is heated in microseconds, expands explosively, creates a shock wave. That shock wave is thunder. The sound propagates outward, travels through the air at the speed of sound, about 340 meters per second, much slower than light. That's why you see lightning before you hear thunder. Light reaches you almost instantly. Sound takes time. Count the seconds between flash and thunder. Divide by 3. That's roughly how many kilometers away the strike was. But back to the direction. The return stroke is upward, definitively, provably, measurably. This is not controversial among scientists who study lightning. It's established fact. High-speed photography, electromagnetic measurements, electric field sensors, all confirm it. The bright discharge travels upward. Yet most people have no idea. They've watched lightning their entire lives, seen hundreds of strikes, thousands maybe, and they think it comes down, because that's the narrative. Lightning strikes down from the heavens, Zeus throwing thunderbolts, God's wrath from above. The cultural story is embedded. The visual illusion is strong. And without slow-motion cameras or scientific instruments, you can't tell. Your eye is too slow. The return stroke propagates in about a millisecond. Your visual system can't resolve that. You see the whole channel light up. It looks simultaneous. Your brain fills in the motion, assumes it came from the cloud. After all, the cloud is where the charge came from. The leader came down, so the flash must have come down too. Wrong. The leader and the return stroke are different things. The leader is invisible. The return stroke is visible. And they go in opposite directions. This is a perfect example of how observation can deceive. You see lightning, you make assumptions. Those assumptions seem obvious, must be correct. But slow down the video, look at the details. And the truth is the opposite of what you assume. The bright flash goes up, not down, up. And once you know this, you can't unsee it. Next time there's a thunderstorm, watch the lightning. Remember, that bright bolt is climbing from ground to cloud. The earth reaching up to the sky, not the sky reaching down to earth. The flash is ascending. Always. Every time. This is how science works. You observe something, you make assumptions. Then you test those assumptions. You measure, you record, you slow things down, you look closer. And sometimes you discover that what everyone sees is not what's actually happening. The obvious explanation is wrong. The truth is hidden. Not because it's complicated, because it happens too fast, or too slow, or at the wrong scale, and your senses can't capture it. Lightning goes up. The bright discharge travels from ground to cloud. The return stroke propagates upward, probably, measurably, visibly if you slow it down. And everyone who watches a thunderstorm sees it backwards, because the invisible part comes down, and the visible part goes up, and your brain only registers the visible. That's lightning, not a bolt from the heavens, a connection between earth and sky. initiated by a descending leader, completed by an ascending return stroke. The flash you see is the ground sending energy upward, charging the cloud, equalizing the potential, the earth fighting back. Lightning strikes up, and you've been watching it wrong your entire life.